RCC, first lecture of the RCC. The lecture first. RCC. Now the structural engineering. In the structural engineering, way analysis. Structural engineering has two components. One is the analysis. Second one is the design. One component is analysis. Second component is design. In analysis, we study the subject like SOM, strength of material, TOS, theory of structure, and in the design component, we study the RCC, pre-stressed cement, pre-stressed concrete, and steel structure design. So in the RCC, in the structural engineering has two components. One is the analysis, second one is the design. In analysis part, we study the strength of material and theory of the structure. And in the designing part of the structural engineering, we study the RCC, reinforced cement concrete, PSC, pre-stressed cement concrete, and steel structural design. In this subject, in this lectures, we will study in our subject that is the RCC. We will study about the RCC here. Let me add the page. If we study we are going to the for analysis. In analysis of the structure, we study the three component. One is the compatibility of the structure. The second one is the equilibrium of structure. Third one is the energy of structure. And if we go for the designing, in design, this study the 5 subvectors, which is very important. We will discuss the conditions. 5 conditions we will discuss here. First is the first condition, that is our structure should be safe, which is the safety. Second structure is the serviceability, condition of the serviceability. And the third is the after the serviceability, structure should be durable. So the durability of the structure. Fourth one is structure should be economic. So the cost of the structure economical structure होना चाहिए. Fifth one is we invest the huge cost on the construction and designing, so the structure should be aesthetically appearance good. So the aesthetic appearance. So if we design the structure, we keep the 5 factors in the point conditions. This first is the safety. Our structure should be safe against the design loading for its design period. Serviceable structure should be serviceable for its design life period. The third one is the structure should be durable. Our structure should be durable for its design life. Let us suppose we design the structure for the 50 years. It should not be the fail in 45 years. If it is fail, it is not the serviceable. So it will the purpose. Structure should be durable and economic. Structure should be designed in such a way that the cost should be economic. And we invest the huge cost on construction and even on the design part of the structure. So the our structure should be looking appearance beautiful. So aesthetically appearance good. Aesthetically good. Looking good. So now let's we discuss this all five factors one by one more. So it should be clear for you. Also first discuss the safety. Yes, safe of the structure. Structure should be safe against the applied loading with sufficient factor of the safety. Our structure, our structure, the structure should be safe. Our structure should be safe against the applied load with sufficient factor of the safety. Let us suppose our structure one structure is taking the load of 10 kilonewton. This is the structure is can take the load of the 10 kilonewton. But our design load for against this load with factor of safety 2. So the factor of safety we are considering here, the factor of safety is 2. So the design load, let me add the page. So the design load will be design load will be applied load divided by the factor of the safety. Here we are taking the factor of safety is 2. So let us in this example we have taken the 10 kilonewton divided by factor of safety is 2 is the 5 kilonewtons. That means our structure can take the load of the 10 kilonewton, but we are it designed for the 5 kilonewtons. 5 kilonewtons. That means the why we are choosing the factor of the safety. Why we are taking this in the factor of safety in the design the structure. We are taking the factor of safety because the if an uncertainty in the construction of the structure and even the some faults or miscalculation during the design of the structure that and even the sometimes poor workmanship, low quality of the construction materials. So that is why we are taking there the factor of the safety for uncertainty in the structure. Now let discuss the second point. The second point is the serviceability. Serviceability of the structure. What is the serviceability? The serviceability means that the structure should be fulfill the purpose for which it is designed. That means the structure should be serve the purpose for which it is designed. Let us suppose we design a building. Let us suppose we design and this sorry. Let us suppose we design a building for The residential purpose for the 50 years is designing life. It should be for the purpose for which it is designed. If it is not the serve the purpose for which it is designed, that is the structure is not serviceable. That means our structure should be serviceable. That means serve the purpose for which it is designed. Okay, I hope you understand. So serviceability. Let us give in a more another example. You know, the if we have this is a bridge. Let us suppose this is a bridge, and this bridge is called said like this in single condition. There is the cracks are observed. This there is the cracks. These cracks are observed here. Cracks. And let us suppose you are passing, you are coming from this side with the car, and if you see this structure, this bridge is sagging like this, and there is the cracks are observed. So you should not be pass here. That means the structure is not fail. It is not collapse. It is the not collapse, but it is not fulfilling the purpose for it is designed. It is not the serviceable. It is not the it is safe but not serviceable. That means this is the case of the structure is not failed. That means the structure is the safe but not serviceable. Not serviceable means our structure should be in such a date. It should be the first, it should be safe, then it should be serviceable. Then we can say our structure is the then we can say our structure is the serviceable. Now the third parameter is come. The third is third point is the durability. So what is the durability? Durability means structure should be durable for which for the designing life for which it is designed. That means our structure should be, let us suppose we design a bridge for the 80 years, and it should be serviceable up to the 80 years. If it is not serviceable, it is not durable up to that period. This means the structure is not durable. So durability means tick open. Let us you can see. So how we can increase the durability of the structure? How we can increase the durability of the structure? We can increase the durability of the structure. How we can? By providing sufficient cover to the reinforcement, and by providing the minimum cement content in the concrete. Minimum cement content means what? The concrete which is mentioned in minimum mentioned in the design mix concrete, or which is the as per the codes which is mentioned for the particular grade of the concrete. This grade we are using in our structure. So the minimum cement content in the concrete. This is increase the strength of the concrete and show it is the structure make the structure durable. You know, we provide the reinforcement cover to the reinforcement because to increase the durability. Still already is fulfilling its purpose to give the tensile strength to the structure, but by providing the cover to the reinforcement, we increase its life, protecting it from the reinforcement and the external protecting it from the corrosion and the external environmental attacks. Now the fourth point up to the first fourth point, let me add the next page. The fourth parameter which is come, that is the cost. No, the structure should be designed in such a way that the cost should be minimum without affecting the without affecting or without compromising the quality and the purpose of the structure. So, structure should be economical. Now, fifth parameter is aesthetic appearance. We invest in the cost aesthetic appearance. Aesthetical appearance. We invest the whole cost on the construction of the structure and then when designing of the structure. So we hope that our structure should be looking very beautiful and aesthetically important. That is the when we so these five parameter I have discussed when we design the structure. These five parameter we should keep into the mind. Now let's we 1 minute. You know the concrete. Let me explain the first before going to the details on the RCC. I'm explain something about the PCC. PCC. What is the PCC? It is the plain cement concrete. Plain cement concrete. PCC. What is it? It is the best. It is the best of mixture of cement, mixture of the cement, mixture of water. Sorry, let me 1 minute. Mixture of water, binding material, coarse aggregate, fine aggregate. Sometimes admixtures also used, admixture, and even fly ash is also be used in now sometimes fly acids. So this is the PCC, the plain cement concrete is the best of mixture of water, binding material, coarse aggregate, fine aggregate, admixture, and sometimes fly ash also used. So let me explain what is the binding material. The binding material may be cement, lime, or gypsum is the binding material. And binding material. What is the coarse aggregate? The is coarse aggregate is the gravel or brick blast. Brick blast means the pieces of the bricks. And the fine aggregate is sand and surki. The admixture will study in the admixture many times. So we will study in the building materials. and sometime fly as also used in the PCC. So this is the PCC. Now, generally in the PCC, we are not use the reinforcement, but we can use it. But but for the calculating the strength calculation, we will not calculate the strength of the steel we are used in the PCC. So normally or generally, we are not use the steel in the PCC, but we can use it. But when we calculate the strength, we not consider the strength of the steel. Okay. Now, what is the uses of the PCC? Let me explain the use of the PCC. Uses of PCC. Normally, it is used in the mass concreting like dams. Another one, the leveling course below the footing or the foundations is used as the leveling course below the foundation. Below the foundation, let us suppose this is the column, and below this column this is our natural ground level, this is the footing foundation, and this below this natural ground level, this is our PCC. So this area is PCC of the desired grade of the concrete as per the code or mentioned as per in our drawings. So this is the PCC, plain cement concrete. Now one more thing, sir. So now we understand what is the PCC and the uses of the PCC. Now I'm something property. I'm explain the properties of the concrete. Then after we'll go in the details of the RCC. So do you know the concrete? We know that the concrete is the brittle material. That means it can fail the suddenly. We will see it later. You know the concrete is concrete is strong in what? Strong in compression. That means its compressive strength is too much. Compression and weak in tension. Concrete is strong in compression and weak in tension. That means the concrete is strong in compression and weak in tension. The tension. Concrete in tension, and so the concrete is fell suddenly. Let us suppose this This is the concrete beam member. If you apply the load P, it can be break suddenly without giving the warning. It can be break like this without giving the warning. So without giving warning. And if you provide there the reinforcement, it will increase the tensile strength. So concrete is weak in tension. So to impart the sufficient tensile strength to the concrete by by reinforcing the fiber reinforcing the fibers well, reinforcing reinforcing the fiber like reinforcing the fiber like bamboo steel geotextile material and PVC. These fiber materials are embedded in the concrete to reinforcing its. So these fiber materials like bamboo, steel, and geotextile and PVC materials are embedded in the concrete to increasing its tensile strength, and as such embedded concrete is termed as a reinforced cement concrete, and and this embedded and this embedded or reinforcement the cement concrete is termed as a RCC, reinforced cement concrete. So I hope all of you clear data. Let me add another page. And due to this generally, now another point is important point. Generally, nowadays we are using steel bars steel as a reinforcing materials in the concrete. Why we are using the generally steel reinforcement or steel bars in the concrete? The reason behind it, generally because the strain compatibility of the strain of the steel and the concrete, the strain compatibility of the steel and the concrete is similar. That means due to the temperature or deformation in temperature effect or any deformation, the concrete and the steels are deformed similarly. So there is no external strain will introduce, and another is the coefficient of thermal expansion. The coefficient of the thermal expansion of the steel and the concrete are nearly equal, not exactly, nearly equal. So the reason behind it, because first, strain compatibility, ability, and second, coefficient of the thermal expansion of the concrete is nearly equal to the coefficient of the thermal expansions of the steel. That is why we are using generally the steel as the reinforcing material in the concrete and in RCC. Nowadays, the research is going on. Normally, the fiber concrete is also on the market, so we can use another this Jupol PVC and geotextiles also we can use to, but generally and normally not using nowadays. Mostly we are using the steels as the reinforcing material. Now, another things, the steel note. Let me write the in the form of the note. Now, the concrete is the brittle material. The brittle materials means don't have the sufficient strain before the failure. That means it is not giving the warning before the failure. That means the brittle material fell suddenly. That means when the load is come on the slab, the concrete will fail suddenly without giving warning. There is the danger for the human life also. So, and the steel is the ductile material. That is, it has the sufficient deformation before the failure. It has the ductility and so sufficient deformation before going to the fail. That means this is steel. That means the steel impart the sufficient ductility to the structure so that it gives the prior warning before going to fail. So I write here the steel imparts the sufficient ductility to the concrete to the concrete so it gives prior warning before fails before fail before fails. I hope all of you understand it very well, and if you like it, please like and subscribe, and so I can make the more